Analyze 9.1.exe using LEDbug. This was initially analyzed in Chapter 3 using basic static and dynamic analysis. How can you get this malware to install itself? Well, let me run it. See what happens. See right here. Oh, it's gone. So it doesn't run very well. Let me revert snapshot, get that back. Now let me open IdaPro. See if there's like an if statement it's checking. Of course, in assembler it's not real if statements, it's conditional jumps. Alright. This right here is saying it's expecting an argument, and if there's not an argument, then it exits the program. Let me go down. It's unclear to me what all that is doing, but let's choose -in since here. Look here. There it is. Double click on it. Control X. I don't know what to make. But anyway, let's run it with that parameter, and then open. Oh, you know what I didn't do when I did that was add parameters, which you can do. You can do it in here afterwards, but you have to restart it. But you can also do it here, which I want to show. File, open, right here, -in. Okay, now I wanna get to some good piece in the code. Let's make it here. This chunk.0. 402B01, and then back in LEDbug control 402B01. didn't work. Let me just say right off the bat, it didn't work. Now let me restart it. Control F2, and we can do this again. We can go up and step through, so we can see exactly what it was doing. It falls through to here. See, this is success. This is when it meets the password. And what we can do is change that. Double click it. The book has a different answer, but this is mine. Now, I'm going to close out of this because if you hit assemble again, it's going to mess you up. But in addition, what you can do is you can say right click, and you can say copy to executable, all modifications. Copy all. And then save file. No password required. Now I'm going to open that other one. And then I'm going to... fact is, we need to put something in argument 2, because if we don't, it'll fail yet again. If we do, it'll blindly accept whatever we enter and then perform the operation related to -in. Okay, what do I have now? Let me see here. I'm going to say debug. Here we can say how arguments are entered. Say you entered arguments after you started, but you got to restart, so junk password. Okay. F2. Control F2. Yes. Go to my breakpoint. I didn't go to my breakpoint. Did something. This program didn't have any breakpoints, so it might have worked. Let's go into Reg Editor, because IN doesn't install. HKL on Windows, current used. HKL on software, Microsoft, Windows. See, there's an extra space. No, that's not the one with the extra space. That's what the answer says. Let's go back to IDA Pro. There's a registry entry in here in strings. There we go. Software, Microsoft. So I'm up higher. There we go. See, those are different. This is a space. This is the XPS. Okay, we're partway done. Okay, okay, so it's installed itself. We figured out how to install itself. Lab 9.1, question 1. What are the command line options for this program? Well, we'll get to that, but 3, how can you use LA debug to permanently patch this malware so it doesn't require a special command line password? We just did that. What are the host-based indicators? Well, we have XPS here as a host-based indicator. And then what are the command line arguments? Well, if you look further down over in runs out, okay, this is the check where it works and it comes down the red, and that's where it does the install. But if it's not IN, it does it could do RE, which means remove, or C. And the way you find out what RE is, it'll come down here and it looks for a third argument. And if there is one, well, either one of these paths will remove. I do know this. See, the thing is, this is the remove. Rename this to remove malware. Okay, it's called in multiple places. And this one is abort program. And that's called many, many places. We saw that up here. If it checks the password, it'll abort the program if it doesn't find it. Okay, CC, don't know exactly. It shows in the chart in the back of the book what that does. On page 536, prints a configuration key, and the way you would find you would follow the red arrow. Jumped on 0. Where was that? CC. It's one of these. It's not that one. It doesn't abort. This one's going here. Debug. Open a key. Query the value. Do a bunch of stuff. Close handle. Print configuration. Config info. Alright, what else? Network-based signatures. I don't know what to say on that one. Let's see what else we have here. So we got a host-based indicator. We know how to patch it. We know command line options. We know how to install it. Now, there's apparently network commands that can be received. There's a reverse shell in here somewhere. Okay. Oh, here we go. Final code path is reached when the malware is installed and not provided with any command line parameters. Malware checks for installation at address 401.0.0.0. The implementation of the default behavior is found in the function starting at 402.360. That's what, at the very beginning of the program, I was wondering what it does. Well, if the key's not there, if the service is not installed, it deletes the executable. Otherwise, yeah, see, it comes down here to aborts program. Otherwise, it does this reverse shell. Let's go in there and take a look at that. Another process. This is a pretty big one. Sleep. Upload. Download. Command. So these are the things that you can be instructed over the internet to do. And somehow, I guess if you read that there's a sleep command coming through, that's a good network-based signature. Sleep, upload, download, command. I don't know, that isn't real specific, that's generic. You can get false positives on that. That's all I'm doing for this one. Lab 9.2. Analyze lab92.exe using ollie debug. What strings do you see statically in the binary? Pro free. File, open, desktop, 92.exe, OK. Strings. Some error messages, imports, and DLLs. Not much else. I don't see very much in here. 2. What happens when you run this binary? Nothing. Let's do that again. Just so we can prove it's doing nothing, I guess. I mean, when we run it in ollie debug, we can see pretty obviously that I'm going to step over until I get to the, meat, which is like, I believe there's a jump. I'm trying to remember where it is. .401. I go back down. Do I have it? I don't have it open. Hide a pro. Scroll up here. Go. So, doing parsing, these are letters. These are ASCII characters. And then, let's see, let's go further down. It does some moving in the XOR. Let's see what else. And then it calls get module file name. So let me put a break right here. Say step over. Well, go actually to get down here. Let me see what's in ESP. Not ESP, EAP usually is the return. Or is it EAX? Could just get module file name. Should have it. Let me sniff a little bit further because it's in this, but I'm not sure exactly. I think ECX. There we go. Follow and dump. Because what it did was, apparently, this is what was set by get module name. Now I don't know the details of what all is going on there, but it just looked to me like if we get ECX here and look at it, it looks valid up here, so I'm sure that's what it is. And let's go to follow and dump. So it's the file name of the current program. Alright, but then if you go further down, we're not changing anything at this point, we're just running this thing. Now what ECX, see right there, is OCL.exe, so it's comparing lab 0902, which is the actual file name, to OCL.exe. It does not equal. Okay, that jump exits, it returns. Return, now we're out. So, okay, how do you get this thing to run? Exit, rename. Open. Okay, where's that funky weird code that checks all kinds of stuff? Okay, checks all these. Let's keep it down here. So it made it to this like WSA startup, which is trying to do a connect. Oh, we had a host name there. It flashed. What domain name does the malware use? Well, we see on the stack. Let's see where it is at this point. Right here, out, get host by name. What's in EAX? Follow and dump. My guess is practicalmalwareanalysis.com. I don't know what to make of that other stuff in there though. Text 64-bit, text 32, or Unicode. Let's try that. What is the significance of the create process A call at 40106E? I assume that's the process that will be used to run a command that's passed through the shell, which this is a shell. Alright, let's go to the answers. There's a lot here. string do you see statically? CMD is the only one they say that is interesting. 2, what happens when you run the program? It terminates, which I saw. 3, 3, how can you get this sample to run? You rename the file ocl.exe. 4, what is happening at 401, 133? Yeah, stringing is being built on the stack. 5, what arguments are being passed to the subroutine? Well, I saw that weird string, which is 1QAZ to WSX 3EDC and a pointer to a buffer. I didn't know the pointer to the buffer. Okay, 6, what domain name does this malware use? PredicalMalwareAnalysis.com, that was my guess. What encoding routine is being used to obfuscate the domain name? Okay, I didn't answer that one, I don't think. The malware will XOR the encoded DNS name with the string to decode the domain name. Alright, 7. Decoding XOR encoded strings. Alright, well, I'm not going to get into that right now. The malware is setting the standard out, standard error, and standard in handles. Okay, number 8. What is the significance of create process A? Okay, the malware is setting standard out, error, and in handles. Since create process A is used with command argument, this will create a reverse shell. Okay, wasn't clear to me that it creates the reverse shell. I thought it ran the command that comes through the reverse shell. Okay, 9-3, we examine lab93.exe, and then there's 3 DLLs associated with this exercise. DL1, DLL1.dll, DLL2, and then DLL3.dll. Okay, what DLLs are imported by lab93.exe? Well, what I can do is open PE view. Oh, it's not the right program. And then go to ports. So it looks like DLL1 and DLL2 are imported. Now, what is the base address requested by these DLLs, each of these? That's question number 2. So, go on to image NT headers, and then down here, and then image base. So DLL1 has 10 million. Okay, same for DLL2. And same for DLL3. Number 3, when you use debug to debug 9.3.exe, what is the assigned base address for DLL1, 2, and 3? Okay. I don't see DLL3 because the program later loads it, but at this time DLL1 got its request of 10 million. DLL2 was pushed to 320,000. Let me look at the answer. 3. says DLL3 is loaded at 3800, but it's not showing as loaded. However, we just happen to know that somewhere in the program, if we open IDA Pro, it does load eventually. I'm just trying to find out where it loads so I can go ahead and, or where in the source code that the programming has it load, so I can go into Ollie Debug and get to that point. What I might do is just run it to the end and see what happens. I'm going to say go. Now I'm going to say view. Executable modules. Oh, DLL3 is there. View. Executable modules. Okay, it changed. It's unclear what happened, but we had an address there. I'm not going to worry about that. Suffice it to say, it was above DLL2's load address. Alright, what does the import function do? Lab93exe calls an import function from DLL1.dll. So I can load DLL1. And just look at functions in here. Or exports, that would be actually where find out what could potentially be called. So it looks like it prints mystery data. Alright. Number 5, DLL2 returns the file name of temp. Oh, I was reading the answer, but that's, yeah, I stepped through that before I had the answer. It was one of the easy ones, so I got it. Lab0903.exe calls write file. So I think it's the second DLL has the file name that it gets. Look at exports. And this return J. Right, spacebar. It's in here. Well, to go through the method I used to find it, I'm going to have to trying to remember. Lab93 calls write to file. This DLL2 return J contains EAX. We'll just put it into the object. The object is passed to write file. Wait a minute. Yeah, I mean the file name. If we go to DLL return J, that's what. We were in the right place. Oh, right here. That's temp.txt. Okay. When lab93x creates a job, where does it get the data for the second parameter? Alright. I don't have a quick answer, so. Huh. That was a guess, but I guessed right that the buffer for the call to net schedule job add from DLL3 get structure, which dynamically resolves. Number 7. Three pieces of mystery data are printed out. What are the following? DLL1 mystery data, DLL2 mystery data, and DLL3 mystery data. Well, I never ran the program, so I'm going to close this out. Okay, let me run that again. 3040. Okay. Let's see. Okay, this calls I'm trying to figure out where the print is for 3, but 1 and 2 are pretty obvious. DLL1 print file. DLL1. process ID. Oh, it's the response from create file A. Well, what comes back from create file A? A handle. It's the file handle. Let me double check. Yep, that's what it is. Now, number 3. I'm thinking that that's the base address. It sure looks like a base address. Let me translate that into hex. BOCO. I don't know. There it is. Alright, so much for that. How can you load the DLL2 into IDAPRO so it matches the load address in Ollie Debug? File, open, DLL2, overwrite. Okay, now manual load right there is important. That's how you do it, and then you enter the address that you would like here.